Okay, so this week we will look into another classifier. So we are still doing the classification. Um, this is this is called instant-based classifier. Um, we will look into a specific classifier called k-nearest neighbor. Okay, so this chapter will cover a key concept that define what is instant-based classifier. And we are referring to k-nearest neighbor classifier and why they are considered as lazy learner. We also look at the method used to measure the similarity between two examples or two samples in our data. And then we will look into the procedure to apply a popular nearest neighbor classifier called KNN. So in the practical side, we will use our software, how we can use that method, KNN method, in performing classification tasks. So we are still doing the classification. Um, and next week we will be doing the naive Bayes classifier. And then after that, we will look into clustering. Okay. Okay, nearest neighbor classifier are defined by their characteristics of classifying unlabeled example by assigning the class of similar label example. So for example, we have a sample of data that we have in our database. So what happens is if we have a new data set or a new record, we will try to compare the similarity between the new sample with the data that we have in our database. So we will assign the label of the sample that has the nearest distance between these two. So the new unseen data will be assigned the class to the sample which has the nearest similarity. So this KNN is a powerful method. This has been used in optical character recognition, facial recognition, and also they look at predicting whether a person will enjoy a movie or not. So this is just simply comparing some of the features that they have collected. We could also use this one in identifying patterns in genetic data. So we are looking at the structure of the genetic data. In most cases, if a concept is difficult to define or it's difficult to describe a concept, but you know it when you see it, then nearest neighbor might be the most appropriate method that you can use. So in most of the classification tasks, people like to perform KNN because this one do not require any training stage. So what happens is you just compare the uh, characteristic of the new sample with the um, data that you have in your database. So basically, you are measuring the distance between the new sample to all the sample that you have in your database. So dia punya keburukan is when you have a lots of data stored in your database, let's say 10 million or no, 10 um, row of data or 100,000 of raw data, you need to compare one by one. So it takes long time to compute the distance for all the rows that you have in your database. Okay? And your accuracy might be affected by features that do not support the classification in which you have noise data. Okay, features that has no relation to the class membership. Okay? So basically, what we have here is that let me take the ini. Where's okay? So basically, what we have is that we just store all the training sample or example in your database. Okay, so this is your um, data. So this is the record that you have in your database. So what happened is that um, if you have a new instance or a query instance, so first you need to locate the nearest training example, which means that you want to find the most similar uh, example that you have in your database, and then you get the class of that sample. So basically, this is your data, okay, and this is your class for this data. So what happens is that when you have a new query data, you will assign the class of this new query data with the class of the nearest neighbor. So in this example, basically we are performing 1 and n because we only look at the nearest neighbor, one nearest neighbor. Okay? But if we have more than one nearest neighbor, we call it k. So k could be 2, 3, 4, and so on. So given new data or the query instance, we take vote among its k nearest neighbor. So basically, we take among the k nearest neighbor, what is the highest number of class that you have, class A, class B, or class C. So we just take both, take the majority of what class that we have in our k nearest neighbor. Okay. This is if you have a discrete value, but if you have the real value, so what you have to do is you will take the mean of the f value of k nearest neighbor. So this is normally we use for regression. This is normally we use for classification. Okay. So in this formula, we are looking at k sample, and we are looking at um, the real value that we have for all the data that all the k nearest data, and then we just take the average, and then we will assign to the new query instance. Okay. So in most cases, we will use this one. Okay, we take the majority voting. Those among the k nearest neighbor, we take the majority class. Okay. So the k here referring to the number of neighbor that we are considering in computing or finding the class of the new instance. But choosing k is another issue. So what is the best k? 1, 2, 3, 4, 5, and so on. So in if you want to perform experiment, we have to perform we have to start from 1 up to n. Okay? So this is the issue that we want to address. What is this n, or what is the k, the optimum value of k? Because different data set will give you different value for k that best classifying your data. Okay. Okay. So what happened is that the k nearest neighbor will pick the k most similar record, and then they will look at the majority label that you have for your k nearest neighbor, and then they will be assigned to the unlabeled test instance. Okay, so for example, like this, suppose we have this data set. Okay, this data set referring to ingredient. So we have some kind of marks or scale for sweetness, crunchiness, and then we also have label. So if we put them in a 2D graph, so we can look at the distribution of the item or the ingredient here, and then um, basically we can group them. Okay, group them into this segment. Okay, so when we have a new data here, for example, the tomato, we will find the nearest neighbor. So it could be belong to the fruits or the vegetables or the proteins. And also it depends on what is K. Okay, so what is K? So if K equal to 1, your class will be different. If your K is 5, your class might be different values. Okay. Okay, the advantage of using KNN is that training is very fast because basically there is no training. You just take all your data and then you compute the distance and then you find the top K. Okay. Uh, this method also learn complex target function in which cannot be described by linear function. Okay, and also you don't lose any information because you consider all the features that you have in your data set. Okay, but the disadvantages is that slow at query time because if you have large number of data or large number of rows, you have to compute the distance from the new instance to all of the data that you have in your data set. Okay, and also a lot of storage required because you have to keep all your um, data in your database, and you are the KNN method can be easily affected by irrelevant attributes ataupun attributes yang menjadi outlier lah or noisy. Has nothing to do with the class, but they exist because they are there. Okay, so what we can do is that we can remove the irrelevant attributes, and then you can perform the KNN. Okay, okay. When we try to perform or measure the distance between two samples, so we could use a few techniques. The most popular technique is called Euclidean distance or Manhattan or LN norm. So this is the general formula. Okay, so um, over here we are looking at the number of dimension of attribute that we have. So we are going from feature 1 up to the number of dimension or the number of features in your data, and we will find the differences among them. Okay, and this n is just to remove the negative value in case this is bigger than x1. If x2 is bigger than x1, then you will have a negative number. So if this is 2, this is what we call Euclidean distance. Okay. But before we can perform the distance measurement, we have to normalize them. So we can normalize them by using the standard deviation or the min-max. So there are some other technique that we can use. So always remember, in the previous example, we have gone through this one. How do we use the min-max scaling in order to normalize our data, because we do not want to have features that monopolize the differences because they have large values. For example, salary and age. So if we find the differences between these two, no, the differences among the samples using salary and also the age, the salary will have bigger number. So we do not want to have the salary to influence the distance. So we have to normalize them. Okay. Okay. Um, let's suppose we have this new sample tomato. Okay, the value for sweetness is 6 and crunchiness is 4. Okay, so we will use the equivalent distance. Okay, so this is the equivalent distance. Okay, the equivalent distance is computed by uh, take, by taking the differences of all the attributes that we have and then square them and then take and sum up together, and we take the square root. Okay, so for example, if we take the tomato with the grape, okay, so the differences will be 6 minus 8 uh, square. So 6 minus 8 lah. And then 4 minus 5. Okay, so di sini you will have minus 2, but you square, then they become 4, and then this one minus 1 square. So basically you have square root of 5, you get this. Okay, so we need to perform the calculation for all of these values, all the samples. So imagine that if you have 10,000 data, then you need to perform all the calculation for all the 10,000 data that you have. Okay, so let's suppose we have only 4 here. So we will take the smallest one. So we can say that the tomato is almost similar to the orange, and then we will assign this fruit to tomato. Okay, so this is when you have k equal to 1 lah. But if you have k equal to 3, that means you will take 1, 2, and 3. Okay, 1, 2, and 3 we have fruits, and then protein, and then fruits. So what happens is that we will take the majority. So this one will be the um, label for your tomato. Okay, so that's how k-nearest neighbor work. They're looking at the distance between the data that you have to the new data that you want to perform classification. Okay, so like I mentioned just now, choosing an appropriate k is very important because this one can affect your model. Okay, so if you look at here, having larger k will cause underfitting. Okay, underfitting means um, during the training you have high accuracy, but when it during the testing you you have low accuracy. Okay, no, it's the other way around. Underfitting, your model perform poorly on the training data but perform well on the testing data. So during the training you are sad because low accuracy. Okay, but during the testing your punya accuracy is high. Okay, because underfitting. Okay, on the other side pula, if we have smaller k, okay, smaller k may cause overfitting, in which your during the training you have, okay, during the training you perform well, but during the testing you did not perform well. So this is what we call overfitting. Overfitting means during the testing your model is too strict and thus your accuracy is low. During the underfitting, your model is too loose, and then when it comes to the testing, your accuracy will be very, very high. Okay. Okay. So when we have larger k, so smaller value of k allow more complex decisions. So boundaries that can carefully fit the training data. So smaller values will be this one, smaller value of k. But if we have, okay, smaller values of k allow more complex decision boundary that carefully fit the training. The problem is that we do not know whether the straight boundary or curved boundary better represent the true underlying concept to be learned. Okay, so for example, like this, we have smaller k, small number of k. So for example, we only have here and then here and here. Okay, so this is the actual k that we have. So we do not know whether this is true or not. Remove this one. Okay, but if we have a larger k, that can be, so we can draw the line in such a way that we can separate them. If we have larger k, okay. Okay, this is the formula that we use to normalize the data. Okay, so the first one is called min max method. So min max method, we only look at the mean value and also the max value of that particular column. So for example, if we have age, uh, age, so this is person A, person B, person C. So this is the age, and this is the salary. So if the age is 19, 25, and 30. And the salary here is 20,000, 10,000, 15K. Okay, so if we perform a distance method, or if we try to find the similarity between the new instant, let's say the new instant is, this is the value, 20 and 15, 20 and 15. Okay, so we do not want to have salary column to um, influence this one because the age value is very small. So what we need to perform is we need to normalize this. So to normalize this value, so basically we take the 19 minus, because we are using mean, my 19 divided by max is 30 minus 9. So that means your value for this one will be 0. Okay, 0. Okay, for this one, 25. So 25 minus 19, 30 minus 19. So over here we have 6 over 11. Okay? So 6 over 11, how much you get? 6 divided by 11. You got here 0.54. Okay? And then the last one will be this one. So 30 minus 19 divided by 30 minus 19, you get 1. So this is 1. So notice that when we normalize, the value for your h will be between 0 to 1. Okay? So similar to this, if we perform the normalization, we can get this 120 to be, so 20 divided minus mean is 10, divided by 20 minus 10. So this is 1, the new value for this one will be 1. Okay, and then we have 10 minus 10 divided by maximum is 20 minus 10. So this is 0. So the value for this one is 0. And last one is 15. So we have 15 minus 10, we get 5. And then over 10. So this is 0.5. So this is 0.5. Okay, so now we can perform we can use the distance method in order to find the distance. Okay. If they are categorical value, so we just use 1 or 0. If they are the same, we put 1. If not the same, we put 0. Okay. Sometimes it's the other way around. Okay. Why is the KNN algorithm is called lazy? Because we do not need to train them. We just compute the distance. Okay. No abstraction, no modeling, no training. Okay. Lazy learning is also known as instant based because we are looking at the instant sample of the data. So instant referring to sample of data. So they are also called as instant based learning or rote learning. Okay. So for instant based learner, we do not build a model. We do not train any model. Uh, in fact, we are using distance method in order to compute the distance. Okay. And for example, like this is the item that we want to classify, and then we said I know a vegetable when I test one. No, a tomato is a fruit by definition. So basically, what we want to look at is the distance between this new instant to the data that you have in your dataset. Another factor that influence the accuracy of KNN is that the number of feature that you have. So this is what we call the curse of dimensionality. The more features that you have in your dataset, the you will struggle to find the best accuracy for your dataset. So just imagine that you have one sample or one record described by 20 attributes, but only 2 are relevant to target function. Only 2 features that can be used to classify them to the target function. So we can use entropy first to select the features, or we can perform some pre-processing. Okay. So in here for the case of dimensionality, nearest neighbor is easily misled when you have high dimensionality. So if you have more than 20, it's better to reduce the number of features to at least by 75% of your features. Okay. Easy problem in low dimensional, hard in high dimensional. So meaning that your high dimensional data basically make your task to classify them further more difficult because you have a lot outlier or noisy data that you have. Okay, and because having a smaller number of features um, will produce different result compared to when you have high dimensional uh, number of features that you have in your data. Okay, so what we can do is that we can use this normal distribution in order to find relevant data, or we can look at the uniform distribution on hypercube. Okay, but most people use this one, normal distribution. Okay, so this is the key. We look at the normal distribution in order to look at whether that feature is can be used for classification using the nearest neighbor. Okay, so in order to solve this problem, because of dimensionality, we can perform feature selection. So feature selection, uh, like you have studied before, which features um, can be used to split your data more perfectly or to get more gain in term of information. So we can use the information gain to determine which features are more relevant to the class label. Okay, but in trying to find the feature selection, we have two methods. Um, the first one is called forward selection, and the second one is called backward elimination. Okay, and these two, there are two different methods. I can show you based on this diagram. Okay, this is based on filtering. Okay, filtering. So what happens is that we will base on your information gain value. So the feature selection is done using this method in which you try to find the feature here based on another algorithm. So your filtering is done here. So when you get the best feature subset, then you can use that one for your actual test. So basically, we are using two different method in order to find the best um, feature subset. Okay, we filter first using algorithm one, and then we perform the evaluation using evaluation using algorithm two. Okay, compared to the wrapper. So in wrapper, we perform the feature selection using the same algorithm that we use in the classification. So basically, they are the same. So they are wrapped into one method. So we perform the feature selection using the same machine learning algorithm. Then when once we get the best feature subset and we want to perform the test set, then we use the same machine learning algorithm again. So this is what we call uh, wrapper feature selection. And I want to so again here, over here we are, when we perform the forward selection, is that we growing the feature to have Okay, let's suppose, let me erase this. So let's suppose we have feature 1, and then feature 2, and then feature 3, and feature 4. So forward selection means we are going to test this one first, and then we look at the accuracy, and then we will include feature 2 again, and then we look at the accuracy, and we will also test again feature 1 and 3, and then take the accuracy. Okay, so compare for this one, we are looking at considering all of this. So feature 1, feature 2, feature 3, and feature 4, and we look at the accuracy, and then slowly we remove one feature at one time, then we compare the accuracy. So we will keep the feature that give you the highest accuracy. Okay, okay, when we perform the feature selection, also we can um, put weighting. So for example, if we have feature 1 and feature 2 and feature 3, so when we put weight like 101, so meaning that we will only select feature 1 and 3. So this on and this is off because the weight is 0. But we could also put a weight something like this. This is 0.8, this is 0.2, and this is 0.5. So whatever value you have in your feature 1 will be multiplied by this weightage, okay, and you get new value. So this is just using random assignment. So another issue is what is the best combination of weightage that you can use to um, perform weighting for the features. Okay. Okay. Let me show you a simple practical exercise that we can get. Okay. This data is collected from the Wisconsin Breast Cancer Diagnostic Dataset. So they have 569 examples and 32 features. Okay? And one feature is the identification number, so we don't need this one. Okay. And another is the cancer diagnosis. So this is your target label. Okay. And we have 30 numerical value of laboratory measurement. So this is the value that we want to look into. Okay. Since they all are in numerical format, we have to normalize them. Okay. So so the first one is we are looking at reading the data, and then we say all the string will be maintained as factor will be false. So that means all this character will be seen as string of character. They are not labeled. Okay, and another one is that we do not want to have this, so we remove that one because they are not relevant to the label of your data. So if you look at the structure of your data, so you will have 31 variable. Okay. Okay, the diagnosis variable is of particular interest because this is the label that we want to predict. So if you look at the diagnosis label, we have 357 belong to benign and 212 belong to malignant. Okay. And if you look at the diagnosis punya ni, they are all in string. So what we need to do is we want to convert them into label or factors. Okay. So di sini we are looking at, we say we will convert your diagnosis string of character to become factor, and this is the label. Okay. So the level that you have is only B and M, so you will convert them into benign and malignant. Okay. So this is converting your string of character to become label factor. So when you look at the data again, so there'll be no more the double quotes. So this is basically the label that we have. Okay, we also can look at the proportion of the table, how many percentage belong to benign and malignant. So we can use the prop.table. So this is basically looking at the proportion of the table that belong to benign and also malignant. Okay. We could also look at all the 30 features. Okay. Basically, we have the mean, no, the radius mean, we have the area mean, and also the smoothness mean for all the 30 feet, basically 10, so 10 times 3 data that we have here. So we can look at the data here. So if you look at here, this is a very small number, this is big number, this is not big and not small. So we want to normalize this value. Okay. So this is the formula that we use. So basically, we are defining a function called normalize. Okay. So when we perform this one, we will have the value of 0, so on. So this is the new value. You can try this one in the R software. Okay. So what happened is that we will apply this function normalize for the data that we have from column 2 up to 31. And then we will save them as data frame and store in here. Okay. So when we look at the data that we have again, look at the value here. The max and min is between 0 to 1. So previously we have bigger number. So now we have 0, between 0 and 1. Okay, the next one will be we divide your data into training and testing. So we will take row number 1 up to 4, 6, 9. And then the remaining will be your testing. And also we will look at the first column. We extract the label and store in here, and similar to the testing data that we have. Okay. So we have two sets of data. One is the training, and the other one is the label. But we only take the first column. Okay. Okay, how do we perform the KNN? So we must provide the training data and also the test data and also the class label. And this is the K that we have. So we need to install and upload the library class. Okay. So we will call them using the KNN. So this is our training data, and this is our testing data, and this is the label that we have. And in this example, we use K equal to 21. Okay. So K could be any number, 10 or 15, up to you. So all the results will be store here because we have the data already, the training data, we have the testing data. So you can try to have another K here. So basically these two are the same, but the number of K will be different and the result will be stored in different name. Okay. So we can perform the cross table in order to compute the accuracy. But the cross table you need to import from the G model here. Okay. So the cross table will look into the test level, and then they will compare with the test prediction. Okay. So this is for K equal to 21. This is K equal to 10. So when we look at the result here, this is true positive, true negative. Your error is this one. So your accuracy is 98. For this one, we have 4. For accuracy is 96%. Because we have 100. So the error is 4 over 100. Accuracy will be 96%. Right? So some of you are using KNN as the classifier for your final year project. So this is a very simple one, but the issue will be what is the best value for K. So you need to try a few times determining which value is the best for K. Then you can fix that K to be deployed in your website when you're deploying your machine learning algorithm. Okay? I think that's all for the nearest neighbor. Any question?